So the last type of factoring that we could have when solving a trig equation is we could have to factor out the greatest common factor. I know I'm going to use the GCF here because I can see that both of my terms have a cosecant in them. I also notice that I have at least 2 cosecants in each term, which means I'm going to factor out, or my GCF is going to be cosecant squared x. Once I do that, I have a cosecant squared x left for my first term, minus a 4 is all that's left in the second term, equals 0. Once I factor out the GCF, then I'm just going to take each factor and set them equal to 0. Then I'm going to solve each factor to get a solution on each side. So here, in order to get rid of the squared, I have to square root both sides, which gives me cosecant x equals 0. And then personally, I'd rather work with sine, cosine, or tangent. So I know that cosecant is the reciprocal of sine. So I can change this to sine. And if I'm going to find the reciprocal of 0, I know that the denominator is a 1 if it's not there. So when I flip it, I get 1 over 0, which is undefined. So then I look at my unit circle and I say, is there ever a sine value that's undefined? And there isn't. So this part of the problem is going to give me no solution. Then I'm going to go over to my other factor. I'm going to add 4 on both sides, which gives me cosecant squared x equals 4. Then I'm going to square root both sides of the equation to get rid of the squared, which gives me cosecant x equals positive or negative 2. Then I want to find the reciprocal of cosecant so that I can work with sine, cosine, or tangent, and I know that the reciprocal of cosecant is sine of x. And if I find the reciprocal of one side, I have to find the reciprocal of the other side, and the reciprocal of 2 is 1/2. So now I'm looking for where sine equals positive or negative 1/2, which is going to be all of my pi over 6's. So pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. And those are my solutions.